Hello class, I hope you enjoyed the previous session on animated cursor vulnerability, and as we were discussing, we left in a mid part where we were trying to figure out the address in the memory which can get pointed to EIP. So, today we are going to start with the same lecture and we are going to extend it to a level where we will be able to put a malicious code inside animated cursor vulnerability, and which will eventually allow us to capture somebody else's machine. And this is the beauty of buffer overflow, where a remote machine can get accessed through a malicious web page. Now, let us start again, and we are going to restart our Internet Explorer so that we can have access to a web page which is hosting an animated cursor. So, as you know, we are pointing to an address http://192.168.72.128/exp.html. And once I point here, you see my EIP is pointing to address 42424242, which is primarily part of my buffer of animated cursor. Now, I need to first of all figure out where that whole buffer is in the memory, because memory contains so many DLL files along with my program. Now, if I go into each and every register, let us start with register EAX and I right click here. So, it does not allow me to get into memory because it is also pointing to address which is out of scope for my application. Now, if I go to ECX register, this ECX register is pointing to a memory of NTDLL, which is again not part of my program. So, buffer cannot be there. So, now we go to EDX register, right click here and say follow in dump. Now, once I see in dump, I did not find my buffer even here. So, that means my buffer is not even available here. So, if I go to the first 4 bytes, right click and say follow double word in the dump. Why I am doing so? Because if you remember in the previous class, I told you the size of an animated cursor, it depends that what kind of animation the developer has built in. If the animation is pretty large, the size of this particular animated cursor file will be large. And in that case, I need to take the memory either from using a malloc function or a dynamic memory allocation need to get happen. That means the memory will be pointing to some other memory, and at that memory location my buffer may be there. So, that is why I am going to follow a pointer to pointer. So, follow this double word in dump. When I click here, still I am not able to get this address, and it is going to point to some other address which is 77FC5340. That means this address is not from my memory. This is a high memory area address. That means it may belong to some other DLL file. The next comes EBX. If I go and follow EBX, but it is pointing to address which is 00000. So, it can also not contain my buffer. So, I go to ESP and say follow this in dump, and again I try to figure out, but I am not able to get buffer even from this register. So, this is hit and trial method. There is no particular direction which is available at this point of time in order to find out where my buffer is in the memory. So, let us now go to EBP. EBP also points to 000. So, no point in exploring this also. So, I go to ESI register, which is a source index register. So, when I follow this in dump, I find it is pointing to another address 00008501. Let us select this and follow this double word in memory, and wow, I got my buffer. So, that means my buffer is indirectly getting pointed by ESI register. So, in order to reach to my buffer, I need an instruction which will be jump double word ESI. That means there should be an address of instruction which will primarily take me to the start of my buffer, and from that point onwards I can start executing byte by byte of a buffer and finally reach my malicious code. Now, in this respect, what we have done here, I am going to note it down that ESI register is more critical for me. So, I am going to open another tab where I am going to explore, click on this E part, that means these DLL files are available in memory. So, I search for user 32 and double click on this. So, I am in a user 32 memory area. So, I am going to search for a command, and this command is jump double word ESI. So, when I find this, I find an address in a memory, and that address is 77D822C0. So, I am going to make a note of this address. So, I open up a notepad and make note of this address, and this address is 77D822C0. So, this is address of jump double word ESI. That means, instead of that 42, 42, 42, 42, if I now point to 77D822C0, that means actually my EIP is going to execute this instruction. And when I execute this instruction, what will happen? This is going to take me to my buffer. And when I am in my buffer, I will be able to take control of a system. So, we are going to replace this 42, 42, 42 with this address. But here we need to understand one more concept, and that concept is little endian format and big endian format. So, whenever a data is getting transmitted from a host machine to the network and back from network to the host, the conversion need to be taken place from network byte order to host byte order. Host byte order. So, actually what happens in host byte order, whatever is represented by MSB, that is the most significant bit, it is reverse in case of network byte order. That means, whatever address is available to me, I have to write that address in a reverse order so that it gets executed. So, this address which I have noted here 77D822C0, it need to be written like C022D877 in the demo.ani file. So, let us open up that file and replace this address. So, we are going to hex edit it. So, hex edit demo, and I am going to replace this address here. So, I will say it is C0 and 22D877, 22D877. So, this address has got replaced. Now, if I save this file and come back to my XP and restart my debugger, so it is again going to pop up Internet Explorer. So, before I type in address here, I want to put a breakpoint in user32.dll at the same address, so that whenever I hit my IIP hit that particular address, it should stop execution. So, I will be able to see step by step what is happening in memory. So, I search for again the same command, and I found that 77D822C0. So, I am going to press F2 here in order to put a breakpoint. So, this particular line goes red, that means there is a breakpoint on this line. So, now I will again come back to my Internet Explorer browser and open up the said IP address http://192.exp.html. So, when I open, see what happens here. I have hit a breakpoint. You read this line, it says breakpoint at user32.77D822C0. That means precisely I have reached that location where jump instruction is there, and my EIP is now pointing to that instruction. So, EIP is pointing to 77D822C0. Now, if I execute this instruction, see what is going to happen. If I say F7 here. So, I have taken to my buffer. So, that means my buffer is going to now get executed. Now, let us do it step by step, F7, 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 F7. Now, I reach an instruction where it says EB16. As you remember in the previous class, I told you this is a short jump, and this short jump is going to take me to some other island, and from that other island I am going to end up into my buffer. So, I press F7 again. So, it takes me to EB77. So, EB77 is going to take me to the start of my buffer. Now, here I have written instead of 43, 43, 43, 43, I typed 90, 90, 90, 90. So, this 90 is basically a no operation. So, that means the cycle gets executed by CPU, but it is not going to do anything. So, preferably whenever we create exploits, we see there are lots of many knobs which get introduced, so that we can smoothly land into our exploit. So, now if I say F7, 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 I am now at start of my buffer. That means I can now append this demo.ini file with an exploit, and this exploit will get executed when we start executing this flow of a program. Now, let us do that. There are two ways to now insert shell code into a demo.ini file. One is you start writing your own shell code. So, by the way, what is shell code? This is a set of instructions which are going to allow me to pick up the code and get executed on the remote machine. That means this shell code is pretty crucial. So, either I write my own shell code, which will be a big task, or I can depend upon some ready made shell codes. So, I am going to depend upon ready made shell codes, and these are available from many frameworks. And one such framework which we are going to utilize in this course is called Metasploit framework. This Metasploit framework has n number of exploits available. So, we are going to use one of such exploits in order to put that exploits in my demo.ini file. So, that whenever a user executes a malicious web page, his machine gets compromised and his shell is thrown out to me. Then because his shell is with me, I will be able to execute any instruction. Now, in order to put a shell code, there are two things which we need to remember. Either we can bind a shell code, which is called shell binding, or we can have a reverse shell binding. Reverse shell binding. Now, these two things we need to understand, what is shell binding and what is reverse shell binding. See, each machine, when it is on the internet, it has an IP address, and through this IP address machine exposes an application to the outside world, and that happens with the help of a port address. So, that means in combination with IP address we have port address. Now, what I can do, I can bind my command.exe file with the IP address and port address of a machine. Now, if I bind this, this is called binding. That means I have binded my shell with a particular port number. Let us say I bind my shell with a port number 444. So, if from the outside world a user wants to access this port, then he is going to specify my IP address colon 444. That means he will be able to access my shell code. But on the other hand, wouldn't it be interesting that as an hacker I am waiting on my machine at my prompt, and all of a sudden somebody else's screen gets open on my desktop? That would be a great thing to happen. So, this happens through another method which is called reverse binding. Now, reverse binding is that somebody binded his shell and he is sending that shell on a particular port number to my machine. That means my machine is available with the IP address and port number, which is a public IP and port number, and this binded shell will travel from that machine to my machine, and this is called reverse binding. So, in this case we are going to utilize a reverse binding stuff, where I will be able to catch hold of the shell code of the victim's machine. Now, how we are going to do that? Let us move back to our Linux box and run a command here which is called msf payload. This will be available to you once you have installed msploit framework on your machine, or you can use it on a backtrack machine or a Kali Linux. So, Kali Linux and backtrack both have Metasploit framework which is available as part of a command. So, I run msf payload, and then I am saying Windows, that means I need a shell code for Windows. I say shell reverse TCP, that means a reverse shell code which I need, and then I specify L host, that is a local host which is my attacking machine, and I want that port to travel to me at port number 4444 in a raw format, and I am going to embed this particular raw format to demo.ani file. So, I will say demo.ani. That means this machine, this msf payload command is going to generate a shell code by using this command and embed this into my demo.ani file. Let us do that. So, when I press enter, the code gets generated and it will be automatically appended to my demo.ani file. Now, let us look at this newly constructed demo.ani file. So, we will say hexadit -b demo.ani. Now, see what happens? All of a sudden there are lots of commands which have got entered into this. So, we were here, this is my C022D877, you would be remembering this address. This address is jump double word ESI, and after that I have no operation, so that I can land smoothly into my shell code, and from here FCE8 the shell code starts, and this shell code goes up to D50A. That means starting from this point till this point, whatever got embedded into my file is going to give me the shell of victim. This is how we have embedded it. Now, let us save this file. Now, go back to Windows machine and start the debugger and make it run. So, as soon as we run, a Windows get open, and I am going to first of all put a breakpoint onto user32.dll, and I am going to do this at an address. So, I search for address, command jump double word ESI and put a breakpoint here F2. Now, go back to my Explorer window and try to open that malicious web page. So, I say http://192.168.72.128.exp.html. When I press this, I am going to hit a breakpoint as usual. You can see it is writing here breakpoint at user32 dot that particular address which we got. Now, we are going to execute this. So, I press F7. So, it takes me to my buffer. So, first 4 instruction 52, 49, 46, 46, then there is a jump from one island to another island. So, EB16, it takes me to EB77, which is next jump, and it is going to take me to no operations, and after that if you see, it is going to execute my shell. Now, before I execute a shell, I will go back to my Linux box, and here I am going to say netcat -lvp 4444. Let us understand this command. This is netcat, this is utility, and I say listen verbosely at port number 4444. That means, when this program is going to get executed, it is waiting for somebody to get connected at port number 4444, and this 4444 port is basically waiting for somebody to give me a reverse connection back, and that reverse connection is primarily of somebody who visited my malicious website, and this is how we are going to demonstrate this animated cursor vulnerability. Now, when I click, it says it is listening on port number 4444, and this guy, he executes his code and as he executes the whole of a code, and I am waiting on this machine, and this hopefully is going to give me a shell, and that shell will be of that particular machine which has remotely access. Wow, as you can see, I got this shell from Windows. That means on Linux box I got a shell of Windows machine, and if I run any command, if I say ipconfig, it shows me the configuration, IP configuration of that machine. Now I am logged in as an administrator here. So this is another security thing which is being getting open to us, and that security rule is that whenever you are surfing internet, kindly surf with a minimal privilege, because if you are surfing with the administrator privilege and somebody like this execute a animated cursor or any other kind of a vulnerability, he will be able to take hold of your machine, and that will have an privilege of the logged in user. Now, because I had logged in as an administrator, this guy got connected to my machine as an administrator. Now, that means I have conquered this machine by virtue of an animated cursor vulnerability, which is primarily a buffer overflow which has happened and overwritten some part in the memory. Now, if I go back to this original machine, that is a XP machine, and I try to open a command prompt here, because I want to figure out what is happening on this machine. I go here and say command prompt, and I say netstat -an more, again the same command. Now, you see it shows me a established connection. It says that there is a connection which is established from 192.168.72 to the 130 machine, which got initiated from port number 1534, and it got connected to a foreign address 192.168.72 to 128 at port number 4444, and this connection is in established state. Now, by looking at this, I will be able to know that my machine is making a connection to some other port, and this guy has, I do not know what he has done on my machine, but eventually as soon as I visited this particular URL, my machine got compromised, and that is a very dangerous situation for my machine. Even if I kill my Internet Explorer, still this guy has an access to my shell, and he can do anything whatever he wants to do on my shell. Now, what could be the other attack vector which may happen with this? Many a time you might have seen that you people receive an email from somebody, and in that email he says that so and so, Mr. So and so, you have won a lottery of, let us say, $100 million. And being such an excited user, because I got $100 million, I used to click on that link, and at that link there may be an implantation of this kind of a vulnerability. So, whenever you are clicking on that particular link, you are trying to access something on your own wish. So, no firewall in the world can stop that from happening, because this is legitimate traffic which got initiated from yourself only. So, if we initiate any connection to the outside world, either on a HTTP or HTTPS, usually most of the firewalls are allowing that traffic to happen from your system. And because of that, I end up in going to a malicious website, and that malicious website may give access to my shell code, and somebody may enjoy all the privileges on my machine. And this is what we have just demonstrated by using this proof of concept. Now, apart from this, there are many other proof of concepts which are available. Now, if you wish to see what all vulnerabilities are available and how that exposure to those vulnerabilities may happen, you may visit this particular resource which is called cve.mitre.org. So, this particular URL, if you visit, it is going to list all kind of vulnerabilities which are available, and these are for all kind of operating systems. It is not that only Microsoft Windows is getting exposed. All kind of operating system, whether it is Linux or a Mac or Windows or any other customized operating system, each and every operating system has some kind of vulnerability lurking. And if this vulnerability is not patched, or you haven't applied a hotfix on that, we are going to be in a trouble. And that trouble is, it can be a remote code execution as I have demonstrated, it can be just stealing of a data, or it may be if that particular operating system sits on some SCADA kind of system, so it may actually compromise your critical infrastructure. And throughout this course, we are going to learn many more other vulnerabilities which may get exposed because of this. So, we learnt about buffer overflow, and we have seen a proof of concept, and this proof of concept was CVE 2007, which was animated cursor vulnerability, and this exposes Windows XP, Windows 2000, Windows Vista, as was written in the advisory which was published on the website. Now, as more and more of these vulnerabilities are in the market, more and more systems are getting affected. So, apart from previously two things, one was called software, another was called hardware, third one we called as a firmware, and finally, we are now ending up with a fourth one which is called malware. Now, malware is a category which is basically a software which is going to do some damage to my system, and this is the next phase which is going to get started, and many new terms are getting coined, like we are now saying, previously we used to say advertisement, now we say mal advertisement. That means malware related some advertisement which may come in the market. So, throughout this course we are going to learn many more things about these malwares, and one such thing which is very hot in the market these days is called crypto wall, where the people just encrypt everything, every data on your system, and then ask for some money so that they can open up that system for you, and this kind of a malware is called ransomware. So, we are going to talk about ransomware, and we are going to talk about crypto wall, we are going to talk about viruses, worms, trojans throughout this course. But for the time being, for this particular session, I have explained you about CVE, animated cursor vulnerability, and how to expose that cursor vulnerability with the help of OLEDBG, that is one of the debugger which we have used, and we have used Internet Explorer, and the victim operating system was Windows XP. Now, hope you understood this all. Apart from this, within this course, we are going to talk more about how to apply encryption into the systems, and that all part will be covered later on. For the time being, thank you very much for paying the attention. Thank you.